Hello everyone, my name is Joshua Gordon. I'm a senior computer information systems major, military science minor from Chicago. In this video, our group will be exploring two influential views on the relationship between minds, brains, and machines. Alan Turing's computational theory of mind and John Searle's critique of it. While both thinkers address whether machines can think, they come to very different conclusions. Today, I will introduce the topic and explain Turing's famous view on machine intelligence. Alan Turing, a pioneering mathematician and computer scientist, is best known for his groundbreaking 1950 paper, Computing Machinery and Intelligence, where he proposes what's now known as the Turing test. Rather than asking, can machines think? Turing reframes the question, can a machine's behavior be indistinguishable from a human's in conversation? If a machine can successfully mimic human responses to the point where an observer can't tell the difference, Turing argues, then it can be said to think. Turing believed that intelligence should be understood in terms of observable behavior, not internal consciousness. He rejected the idea that there is something special or non-physical about human minds that make them uniquely capable of thought. To him, the brain is like a digital computer that processes information. If machines can replicate those processes, they can be intelligent. This behaviorist approach was a radical shift, moving philosophy and cognitive space away from metaphysical questions and toward empirical tests of intelligence. Turing's view laid the foundation for modern AI and machine learning research, inspiring generations of scientists to explore the possibility of intelligent machines. In the next section, my partner will introduce John Searle, whose work responds directly to Turing's ideas and challenges, and the assumption that computational processes alone can explain consciousness and thought.
Hi, my name is Rashid, a sophomore political science major with a double minor in public policy and public relations. Now I'll turn to the work of John Searle, philosopher who strongly critiques Turing views that a machine can think just like humans. In his 1960 paper, Minds, Brains, and Program, Searle introduces the famous Chinese room argument, which challenges the idea that computers truly understand or have minds. Searle asks us to imagine a person in a locked room who does not understand Chinese. They receive Chinese characters through a slot, follow a set of rules in English, and manipulate the characters, and produce Chinese responses that appear meaningful to outsiders. However, the person inside the room has no understanding of what any of it means. They're simply following instructions. Searle argues that this is what computers do, manipulate symbols based on syntax, not meaning. They may appear to understand language, thought, but there is no actual understanding, no intention, or aboutness behind the responses. In contrast to Turing, Searle emphasizes the consciousness and mental states involved more than the processing inputs and outputs. They require biological grounding and the kind of material brain are made of. Searle's point is that the machine might stimulate or simulate thought, but that it is not the same as truly having a mind programmed by themselves, lack of understanding. So even if a machine passes the Turing test, it doesn't necessarily prove that it thinks. If only proven it can imitate thinking behavior. Now, Turing made me think differently about intelligence. If a machine can act like it understands, maybe that's enough to call it thinking. Are we right? What do you guys think?
Hello, my name is Malia Andrews, and I am a junior criminology major from Camden, New Jersey. Today, I'll be talking about comparing and contrasting Turing and Searle's thoughts. So, in this section, I'll compare and contrast the two views we've just discussed. Although both Turing and Searle are concerned with whether machines can think, they differ significantly in their assumptions and conclusions about the mind, the brain, and machines. Turing takes a functionalist and behavioralist approach, suggesting that the mental process can be, like how basically our brains, basically it can reciprocate or copy and make a be just like a human, think like a human, talk like a human. And so if these machines can match human behavior, he is less concerned with the internal experiences of the machine and more focused on whether the actions are indistinguishable from those of a human. In contrast, Searle insists that the internal experience, intentionally meaning and understanding, is essential to having a mind. His biological naturalism argues that the mental states depend on the physical properties of a human and are no program alone, regardless of behavior, can reciprocate that or replicate that. Basically, he's saying that um, humans, or he gave an example, or an example would be like he was talking about how, like, I guess you can make someone think that you know something in a sense, but not really know it. And so that's kind of the sense what he's saying with the machines, is that the machine can talk and make it seem like they think it's a human, but truly there's nothing behind it. And so another major difference lies in their views on stimulation versus duplication. Turing believes that if behavior can be stimulated well enough, it's functionally equivalent to thinking. Searle argues that stimulation is not a duplication. A computer can simulate understanding and still not understand in a way a human mind does, which is kind of what I just said, but yeah. And despite their differences, both Turing and Searle have had a lasting impact on philosophy of the mind and AI research. Turing work sparked the development of artificial intelligence, while Searle's argument continued to challenge the field to confront deeper questions about consciousness and meaning. Searle challenges the very foundation of AI and the idea that a computer could literally have a mind. So, despite these fundamental differences, both thinkers have left a huge impact and legacy in the field of philosophy and cognitive science and artificial intelligence. Turing is often credited as a foundational figure in computer science and the father of AI, really, inspiring generations of research to build machines and capable intelligent behavior. Searle, meanwhile, has a critical role in keeping philosophy questions about consciousness, meaning, and the nature of understanding alive with the AI conversation. His critiques remind us that behavior is not necessarily the same as the experience, and that the question of the mind and meaning may not be solvable through models alone. So when I say models alone, he's saying that basically, just because the computer can act like the mind and be a model of the mind does not mean that it thinks like the mind or is like the mind or is a good example of the mind, because it's a computer, so it cannot think like a person outside of is exactly what you asking. There's no emotion behind it, there's no thought behind it. It's just a computer answering questions that it knows. So in summary, Turing and Searle represent two powerful opposing visions of machine intelligence. Turing's functionalism opens the door to the possibility of artificial minds through behavior and imitation, while Searle's biological naturalism closes that door by emphasizing the irreplaceable role of biological consciousness. These debates continue to shape and challenge the evolving landscape of intelligence, ensuring that both philosophical questions remain central to the field.
Hi everyone, my name is Audrey Nelson. I'm a junior economics major from Westwood, New Jersey, and I'll be wrapping up our presentation by examining some of the key criticisms and implications of Turing's and Searle's views. So, one common criticism of Turing's approach is that it may be too focused on appearances. Just because a machine behaves intelligently doesn't mean it truly understands what it's doing. Critics argue that passing the Turing test may only reflect sophisticated mimicry, not real thinking or awareness. On the other hand, Searle's biological argument has also been challenged. Some argue that insisting thought must be tied to the biology of human brains is too restrictive. If intelligence is about processes, not material, then perhaps non-biological systems could develop consciousness in ways we don't yet understand. Despite these critiques, both thinkers offer valuable frameworks. Turing encourages us to ask what behavior counts as intelligence, while Searle pushes us to think more deeply about what it means to truly understand or have a mind. Their debate highlights the tension between functionalism and consciousness, simulation and meaning, and challenges us to consider whether thinking is purely mechanical or something more. So as we continue to explore artificial intelligence and its role in society, Turing and Searle remind us that understanding the mind is not just a technical challenge, but a philosophical one as well. Their work helps us to question what it truly means to think and whether machines will ever cross that line. So thank you for watching our presentation. We hope it clarified two of the most influential perspectives on minds, brains, and machines, and inspired you to think more critically about the future of AI and human thought. But as well, to end our presentation, each of us wanted to share a quick takeaway. So Rashi, Joshua, Malia, and I as well wrote some things that we took away from it. And Rashi said, Turing made me think differently about intelligence. If a machine can act like it understands, maybe that's enough to call it thinking. Well, Joshua said, Searle's Chinese room helped me realize that just copying behavior isn't the same as truly understanding something. Malia puts in, I found it interesting how both philosophers push us to question what thinking really means, whether it's about behavior or consciousness. And then for me, I said this project was really interesting. It showed me how to question the mind just a little bit more about minds and machines, and then just made me just think about science in a different way and more philosophically and personal too now. So like I said at the end, thank you again for watching our presentation. We hope this helped you think more deeply about the differences between Turing's and Searle's views on minds, brains, and machines, and give you a better sense of why these questions matter for how we define intelligence, understanding, and ourselves. Thank you.